Hello everyone. I hope it is clear now. We are facing some technical difficulties and so we got delayed with this start of this live session. So thanks for keeping your patience and I am looking for a good participation from your side because over last 4 weeks we are having discussions on several topics associated with this course of fundamentals of conduction and radiation. And as you have seen, we have already covered 4 modules. So module 5 is live now. And so far you have idea about the 1D steady state heat conduction. That is, if I just want to have a quick recap, we started with discussing some fundamentals of thermodynamics and its relation with the topic of heat transfer. Then we talked about the Fourier's law of heat conduction and accordingly the properties like thermal conductivity and thermal diffusivity. Then we generalize the basic heat diffusion equation in all the 3 relevant coordinate systems, the Cartesian, cylindrical and spherical coordinate system. Then in week number 3 went for the specialized case of 1D steady state heat conduction. In several practical cases, the heat transfer problem can be modeled as a steady state 1D heat conduction problem, and that's what we have discussed in details, both at the absence of heat generation and also with the presence of heat generation. Certain special cases like the internal heat generation, variable thermal conductivity or temperature dependent thermal conductivity, etc. was also discussed in module number 4. Now in module 5, we were talking about the conjugate or conduction convection problem in the form of extended surfaces. And in this live session, I would like to keep the discussion restricted up to week number 4. I have picked up a few comments that you have made in the portal and also in that Google Sheet that was shared a few days back. And I shall be discussing about those 4 or 5 points here, and also whatever questions that are coming from your side, I would like to talk about the same as well. So please feel free to write now whatever comments we have. It is much easier to explain it verbally instead of typing something on this. So as I wait for your comments, I'd like to talk about if you have the comments which I picked up from the portal. Like there are several common questions that was raised regarding 2 or 3 questions available in the assignments. So I'd like to first talk about them. So this was a question which was given in assignment number 2, question number 8, which has raised several comments from your side and for all the right reasons, because there was a mistake in this. We noted the mistake after making the assignment public, and also we saw all the comments, but it was not possible that time as per the system to change the question, as some of the students may have already submitted the assignments, and that's why we had to continue with this particular one. But definitely there was a mistake in this one. Like as you can see, I have picked up one of the comments that was given in the portal, where it mentions that in that question you ask the heat flux at the right end of the wall, but the given unit is Kelvin per meter. So this was a question that we had. Consider a plane wall of 100 millimeter thickness and 100 watt per meter Kelvin thermal conductivity. If its left and right surfaces are maintained at given temperatures, then the heat flux at the right wall is, now this is the one that was problem, definitely it is wrong. In fact, while typing initially I thought about asking the temperature gradient and typed accordingly, then I changed this temperature gradient to heat flux, but forgot to change this particular unit. And so the correct question of course should have been in terms of heat flux, and in that case the unit should be whatever we use standard, that is kilowatt per meter square or just watt per meter square. But as we don't have any options of changing that, so whoever has solved this using either finding the temperature gradient or most likely in terms of heat flux using any one of the units, we are going to give them marks. That is, I repeat, we are continuing the heat flux as the correct question, and whoever has written or found the value of heat flux in any unit in kilowatt per meter square or watt per meter square, they will be getting the credit for that. accordingly we have informed our NPTEL office, and the correction probably will be reflected in your scores very soon. And should I discuss the solution of this? Because it's very straightforward problem. Here we are talking about a plane wall. We are talking about a plane wall of given thickness L, and here this L is given to be 100 millimeter. Thermal conductivity is given as 100 watt per meter Kelvin, and T1 and T2 are the temperatures. In this case, it is given that T1 is equal to 400 Kelvin, and T2 is equal to 600 Kelvin. And then now you can easily solve this. Like first you should calculate the temperature gradient. So dou T dou S can be approximated as T1 minus T2 upon x1 minus x2. So it becomes 400 minus 600 divided by 0 minus 100 millimeter. Be careful about this length L given in 100 millimeters. You have to convert this to meter, which becomes 0.1. So accordingly we have the answer to be, or temperature gradient to be 2000 Kelvin per meter, which was supposed to be the first answer. Probably in your portal you are seeing the correct answer as 2000 Kelvin per meter, but as I have mentioned, that will be corrected during the review of your evaluation. So once you have the temperature gradient, you can easily calculate the conduction heat flux as minus K dou T dou X, or I should have written in terms of the exact differentials, because from the left to the right, it's a steady state 1D steady state heat conduction problem, so the value of heat flux remains the same on both left and right one. So that is one very glaring mistake from our part, but we have taken measures to correct that one. Picked up a few comments. Is there any live comment? Okay, so this is another one again related to assignment 2, question number 7. So this is one comment that I got. Respected sir, in the assignment 2 Q7 asks about the option with the least thermal conductivity, and the option 3 aluminum foil is shown as the correct answer. However, according to some of the standard books, aluminum has quite high values of thermal conductivity. I have also attached a table mentioned in the book Incropera. Kindly help me figure out where I might be wrong. And actually I have found one or two more questions in the same line. That's why I have picked this one up. So here you have to keep in mind that aluminum and aluminum foil are separate things. Aluminum is a metal which has quite high thermal conductivity. For aluminum, the thermal conductivity is approximately in the range of 237 watt per meter Kelvin. However, aluminum foil is an insulator. It is, all of you must have seen the aluminum foil, which is used for packing the foodstuffs, etc. Like quite often for keeping our food hot for a long duration, we wrap them using aluminum foils or put them in boxes made by aluminum foils and close it, and generally remains hot or at a reasonably hot over quite a few hours. That is because aluminum foil has a very low thermal conductivity and it acts as an insulator. So aluminum and aluminum foil are separate things. Thermal conductivity for aluminum foil, that actually depends upon the nature of the foil, but for most of the common aluminum foil that you can purchase in the market, thermal conductivity is a range of 1 into 10 to the power minus 4 watt per meter Kelvin. So it's a very small value of thermal conductivity we are talking about. 1.5, 1.6 into 10 to the power minus 4, it is often in that range. So you can search over internet, but over internet getting reliable source may be difficult. So the numbers that I am putting here, this is again available in the book of Incropera itself. I don't know which version of the book that you are using, but towards the back end of the book you will find there are several tables given, several tables related to the data, several property tables, and you please search for, I can't remember the table number, please search for the table containing the properties of insulators, and you will find the aluminum foil there. Quite a few grades of aluminum foils are mentioned there. And if available to you or to the library of your institute, you can also find a thermal energy data book or thermal data book to get even wider database for different grades of aluminum foil. It will be eventually in the range of this 10 to the minus 4 watt per meter Kelvin, or even lower for certain special grades. And this is another comment that I received, again 2 or 3 different versions of the same comment I have received. It mentions that assignment 3 question number 10, but for as whatever I have got as per my record, it is question number 7 actually. It is given that a part of the problem statement is given, and this is the problem that I was talking about. a composite wall of an oven consists of three materials, two of which are of known thermal conductivity. So this Ka and Kc they are given, and thickness La and Lc they are also given. The third material B is sandwiched between the two and has a thickness of 0.15 meters. So LB is also given. Under steady state, the inner and outer surfaces are maintained at 20 degrees Celsius and 600 degrees Celsius respectively, and an oven temperature of 800 degrees Celsius. Now, that's why you have the confusion. Uh, I think I already responded to the comment raised by 2 or 3 other students, but again, this question kept on coming back, so I thought about answering it here. Probably this inner and outer term are raising some confusions, but here actually the inner and outer term I have used in conjunction with the room, but as per the diagram this oven side is mentioned as the inner one and this side is mentioned as the outer one. So probably you should treat this one as opposite way, that is TSI, this inner one, inner to the oven, that is maintained as 600 degrees Celsius. So this is 600 degrees Celsius. The outer room side temperature is 20 degrees Celsius, and this oven air temperature is given as 800 degrees Celsius. So yeah, probably you were right that here instead of writing inner and outer, I should have written outer and inner, because this inner here corresponds to 600 degrees Celsius and this outer corresponds to this 20 degrees Celsius. But I hope most of you will be able to get the correct picture, because it is only logical that if the temperature of air inside the oven is 800 degrees Celsius, then the surface adjacent to that, that is this particular surface, that is the one likely to be at 600 degrees Celsius, not 20 degrees Celsius. Whereas this surface is on the other side of the oven towards your room side, so it is likely to be at the low temperature only. So I guess most of you have got it correctly. I repeat here, this outer and inner terminology was used in conjunction with the room. Here I mentioned that inner as 600 in sorry, this outer and inner that you have mentioned, this inner and outer that I have mentioned, I mentioned in conjunction with the room, because I want to talk about the inner temperature of the room as 20 degrees Celsius and outer in corresponding to the room is 600 degrees Celsius. So these three are from the assignments. Now there are a couple of questions that was given in the Google Sheet which was circulated during the announcement of this. Someone has asked me that I have been trying to start my preparation for GATE exam, but he seems to be stuck with several things, and it's very difficult to suggest you something, but it seems you have a quite busy schedule, because you are having college from 8:30 to 4:30, and then it takes time for you to come back, so you must be exhausted, and also there are so many things that you are doing here. But I would suggest you try to make a suitable routine which should incorporate all the assignments given by NPTEL course and also from your college, but at the same time that also provides you sufficient time for your rest. Maybe I don't know how you travel from your home to the college, but the travel period you can use for studying something, maybe revising some task or some lessons that you have learned in the last night, and then if you have any time in the early morning, probably you can study something in the early morning, and once you get back from the college, take some rest for some time, maybe 1 or 2 hours, and then try to solve your assignments, etc. Practice something for a couple of hours, and then next morning again when you are going to the college, you can revise whatever you have studied last night. But somehow you have to manage, particularly the weekends and holidays that you get. You try to give as much time as you can, and one suggestion that I have for all of you, that is always try to read some good book instead of directly trying to solve some problem using any sample handbook, or maybe some books which contains lots of problems. Always try to first go through a proper book, try to understand the theory properly, and if you have understood the theory properly, then you will find it much easier to tackle it with any kind of numerical problem, because you already know the basics. Like if I talk about in corresponding to the course that we are doing here, if you have understood how to develop the generalized version of the heat diffusion equation, say in Cartesian coordinate, then it becomes very easy to pick up the version of the equation suitable to a particular situation that you are handling. Whenever a problem is presented to you, then you can easily identify from the given situation is a 1D problem or a 2D problem, whether you're talking about a steady state or unsteady situation, whether the properties like thermal conductivity is a constant one or is a temperature dependent one, is there any volumetric energy generation or not. And then first always write the generalized heat diffusion equation and then strike out the terms which are not relevant to the problem and get the final equation, and then try to solve the final equation using the first principles, just the way we solve any differential equation, ordinary or partial differential equation, whatever is relevant. And if you are doing that way, then you don't have to remember any form of the equation. Only thing that you are remembering is the generalized heat diffusion equation, which again you can derive. Like during a particular exam, if you have forgot the form of this generalized heat diffusion equation, but if you know how to derive the equation, then you can do that within 2 minutes, because you know that you just have to take a differential volume, balance the energy fluxes that is coming in and going out of that, and you have the final form of the equation after suitable alteration or suitable arrangement. So once you know how to develop the equation and that form of the equation, then from there you can easily derive any simplified version of the equation, and then you can solve it using your mathematical background. So you hardly have to remember anything in that case. The concept of thermal resistance, of course, is a quite easy one, and but you have to be careful that in which situation you can make use of the concept of thermal resistance and where you can't. As we have already seen that the concept of thermal resistance can be used when we are dealing with a steady state, 1D heat transfer problem, constant thermal conductivity, and also you know volumetric energy generation and probably no change in the cross-section area as well. So when all these conditions are available, then only you can go for the concept of thermal resistance. But if any of the conditions are not available, then the concept of thermal resistance is not applicable. And therefore, uh, as the concept of thermal resistance is not applicable in that case, but if you are still trying to apply the concept of thermal resistance, then you may get some error in that situation. And therefore, if you are just trying to remember the way of estimating the thermal resistance without trying to understand in which situation you can make use of that, then you will be landing in a soup. So always try to get the basics. That may take some time initially, but that will save lots of time in the end. And once you have started understand the basic, then it is important to solve some problems. Like quite a few have asked me in the portal that I have given just I have probably discussed just 2-3 problems while taking the lectures, and there are some more problems given in the assignments. Of course, in the scope of lecture, it is not possible to talk about too many problems as we have limited time. You please try to solve more problems on your own, because if you pick up any standard textbook, you will have lots of exercise at the end. Try to solve those exercises. First try to solve on their own. Then if you are not able to find a solution for any one of them, you may discuss with your friend and have some kind of group study kind of thing to find a solution. If you are even in that case also you are not getting a solution, then you may refer to some solution manuals. Like if we are taking in the book of Incorporated and Dept as the standard textbooks for this course, now the solution manual for that particular book probably is available over internet. You can search that and try to see if you are able to download that solution manual. So but please, even if you have the solution manual, just don't go to the solution manual at the beginning itself. Please try to solve the problem on your own, starting from the very basic with thinking carefully, following a step-by-step procedure, because when you have the manual with you, you will be able to get the solution from there. But when you are going to solve some numerals in the exam, you don't have the manual with you. There you have to apply your own brain only. So try to solve the problems on your own. That will increase your confidence, and that will also allow you to have a better approach of tackling any problem during the exams. Yes. I had one more question. So if it just one more. Okay. So this was one question that came from someone. The answer is already available in the portal in the concerned web page. How the marks of the assignments are taken into account in final mark sheet. Firstly, I will answer the latter part of this question. That is, in week 1 to 4, only 2 or 3 numerals are explained, but in assignments there are a number of examples which I was actually talking about just now. We have limited time, so we can't solve more problems. You please try to solve the problems on your own. If you are facing trouble with anything, you can write to me. I shall always be happy to help. And then and also the sample solutions for these numerals will be provided to you very soon. As soon as the submission of week 4 is closed, I shall be providing you the sample solutions for the numerical problems given in all assignments starting from 1 to 4. Now regarding the grading scheme, it is given on the course web page. You can check that. During the final grading, the weightage of the assignment that is 25%, and your exam score is 75%. Your final exam will be out of 100 marks. So whatever you are getting there, 3/4 of that will be taken. That is, it will be converted to 75%. And from the assignments, there are 12. It's a 12-week course. So you know there are 12 modules, and each week we will be having one assignment. Out of the 12, the best 8 will be taken. So it's not that while estimating this 25% you are taking marks for all the 12. We shall be taking the best 8 out of this 12, and then the average marks out of this 8 will be calculated, and that will be converted to 25%. So this two together is going to be used for your final grading, final score calculation. But and be very careful. While 40 is the pass mark for this course, but you must score at more than 10 in the assignment part and more than 30 in the final exam part. If you get more than 40 in total, but your exam score is falling less than 30 or your assignment score is falling less than 10, then you will not be able to pass this. So these are the minimum criteria numbers that you should get in both assignment and exam score, and then only be able to clear. And I am very much confident that if you are able to follow the lectures properly, lectures from both me and from Professor Dalal, who is also taking half of this course, you will be able to clear the course confidently or quite comfortably and with very good marks as well. So is there any question in the portal? Okay, I just now got one question where Arnab Nandi is asking how can I prepare for GATE 2021 using NPTEL? Oh, okay, Arnab, it's probably a question that many of you are thinking. Mm. Now, the preparation for the GATE, there are quite a few books available which discusses the GATE papers. Maybe you can try to solve the question papers from the previous years, and now it is an MCQ based exam, as you know. So if you solve the exams for or question papers for at least for last 5 years, you will be having some idea about the patterns. From there, try to identify that from which portion on average how many questions are asked, because while mechanical engineering is a huge course, you may be having your strength in certain subjects and weakness in certain others. Like you may be quite strong in thermodynamics and heat transfer, and maybe a bit weak in machine design. So try to figure out a bit that how many questions are asked from the thermal part, how many from the design part, and if you can identify that consistently from this portion more questions are being asked, then you probably can, and that is within your strength, probably you can give some more emphasis on that during the preparation. And it's definitely it's a exam where the absolute mark doesn't matter, rather it's only the comparative marks, that is you have to score more than the others. It's not that you have to get 100 out of 100. So you have to outscore the others to get a good rank, and therefore it's not that you always have to answer all the 100 mark questions or 100% of the questions. Rather, if you can answer say 50 questions quite confidently, that may be sufficient for you. So that's what I am saying. Instead of trying to focus on everything, first try to increase your strength in the subjects where you are comfortable, and once you feel that you have fully covered that, then move to the other subjects. That probably will allow you to expand your scope for this. And once you have, and again as I told earlier, it is important to study the basics, because once you have understood the basics, then it is quite easy to apply that concepts for other things. Like say, if I talk about thermodynamics, if you know the basics of thermodynamic processes and cycles, then you will find it quite easy to analyze any thermodynamic process or any thermodynamic cycle. But or say if a thermodynamic process is given, then and if you are just trying to remember what is the work done associated with that, then there is more chance of for you to commit error instead of if you are trying to calculate the value of the work just by performing the integration. If it is a closed system and simple compressible one, then the work will be integral PdV. So once you know the process equation from integral PdV, you can easily get the work output for that. But if you are trying to remember the expression in for that particular process, then there is more chance for you to commit error. So always try to stick to the fundamentals, and if your fundamental is strong, then no one can stop you from achieving good scores in any exams, not only GATE. Yes. There is no other question as of now. So should I wait for some more time? In this, I'm coming back to the MOOCs course that we are handling here. So you have seen that we have now moved to the topic of extended surfaces, where the conjugate conduction convection problem is being handled. Here you are still talking about 1D steady state heat conduction, but in the direction perpendicular to the direction of conduction heat transfer, there is convection happening. It is from the peripheral areas of the surface that we are talking about. Convection is happening from there, conductivity losses is there, and accordingly we are dealing with conjugate problem. In the subsequent use, we shall be moving to the two-dimensional heat conduction. Two-dimensional heat conduction is again very relevant. 1D heat conduction is a more specialized case, more restricted case. 2D heat conduction, almost in most of the practical problems, can be treated as a two-dimensional heat conduction instead of going to 3-dimension. That's why it is very important to understand how to estimate heat conduction in 2D. And of course, it is again more difficult compared to 1D. There are several techniques, graphical techniques, analytical techniques, and numerical techniques as well. We shall be discussing about all those techniques. Then we shall be moving on to the transient heat conduction. The problems that we have dealt so far, they are steady state. And then in transient heat conduction, we shall be talking about the time required for a certain amount of temperature change, time required for energy to progress from one side to another side of a given system. And that will finish our discussion of the conduction part in week number 8, where we shall be having another live session to respond to any other queries that you may be having. And then last 4 weeks we shall be having the radiation heat transfer. I shall be back in week number 9, as I have told during the last video that we recorded. In week 9 and 10, I shall be talking about the fundamentals of radiation heat transfer, explaining you different kinds of terminology associated with radiation, different kind of radiation intensities, radiation heat fluxes, properties of ideal and real surfaces, concepts of black bodies, grey bodies, or grey surfaces, Kirchhoff's law. These all we shall be coming in week number 9 and 10, and then again Professor will be taking care of the last 2 courses, talking about the radiative exchange between surfaces and also the role of the participating medium. Yes. So, as there is no question, then probably I can stop it here. Okay. Some questions just popped up. Okay. Okay, Arnav Nandi is asking, sir, please explain what is the crossover radius. Now, Arnav, I'm not sure what do you mean by crossover radius. Are you talking about the critical thickness or critical radius of the system? Because this terminology is a bit new to me, and crossover radius, I'm not sure exactly what do you mean here. If you are talking about the critical radius, which we have already covered in week number 3, that I can talk about. If you can listen, please, you can write back again, because in which context you are getting this terminology crossover radius, I am not sure. In general heat conduction or general heat transfer, generally don't have a term something like crossover radius. But critical radius that we have already talked in conjunction with the curvilinear coordinate system, like as you have seen when you are talking about say a cylinder, a hollow cylinder which is having an inner radius and outer radius, and then it is wrapped by some kind of insulating material, then the rate of heat transfer depends on the thickness of that insulating material, of course. And as we have discussed, okay, so you are saying that it is crossover radius still. Can you write a bit more in which, where you have found this term, in which context, or maybe some book or something where you got this term? So it's not critical radius that you are talking about. So it is our hollow cylinder. But again, that hollow cylinder is the one that I am talking about, where we talk about the critical thickness of insulation. Like if you are talking about a hollow cylinder, then the conduction is possible on across the material of this, and you may have conduction on the inner side and outer side, or you may have conduction again, like if the cylinder is wrapped by some other material, then we may have conduction again. So if the cylinder is wrapped by certain material and you are having conduction heat transfer, then the rate of conduction will depend upon the thermal conductivity of both the materials. And of course, the final condition, after that layer of insulation you are having, we may have the convection. So the convective transfer depends upon the surface areas, and as we have seen that as the thickness of insulation increases, the rate of both conduction and convection that changes. And accordingly, the net rate of heat transfer that depends upon the thickness of that insulating material, and up to a certain level, to a certain thickness of insulation, the rate of heat transfer increases, and then the rate of heat transfer keeps on decreasing. And that thickness we call is the critical thickness of insulation, or that can be talked about as the corresponding radius of the cylinder, including that layer of insulation, is generally called the critical radius. The crossover radius probably use this. Okay, maybe let me see if you are talking in terms of this one only. Okay, I can tell you. As we have seen that if you talk about a hollow cylinder which is wrapped by some layer of insulation, and then as the thickness of insulation increases, let us neglect the thickness of the insulating material itself, just talk about the thickness of the insulating material. Now as the thickness of insulation increases, the corresponding conduction resistance increases, because you know that the conduction resistance is proportional to the thickness of insulation. Whereas for convection, the convective resistance is dependent on the surface area associated with this, because you know that convective resistance is 1 upon HA. Now as the thickness of insulating material increases, the peripheral area involving the insulation, that also keeps on increasing, so convective resistance that decreases. So what is the effect then? As the thickness of insulation is increasing, the conduction resistance increases and convection resistance decreases. So if we plot these two resistances with respect to the thickness of the insulating material, then you will find that your conduction resistance keeps on increasing continuously, convection resistance keeps on decreasing continuously, and there of course will be a point where these two resistances cross each other. You may be referring to that particular one as the crossover radius, but I am not sure, because as I have told, it is not a standard terminology. And this crossover radius not necessarily is a point where you will be having the critical radius. Like your critical radius can of thickness, that the thickness of the insulating material corresponding to the critical radius, that is the maximum level of heat transfer, or the minimum level of total thermal resistance that can lie on at that particular point of crossover, that can lie on its left, that can lie on its right. So that crossover point generally has no separate significance in heat transfer, but we are more concerned about the critical thickness of insulation, which I have explained during my lecture only, week number 3, about how to estimate. Because you know the expression of conduction resistance, you know the expression of convection resistance in cylindrical coordinate system. We just need to add them and then differentiate that with respect to the thickness of insulation, or maybe the final radius and outer radius, and equate that to 0. So the corresponding value of the radius is going to, value of outer radius is going to give you a point of extreme, and then using the the differentiating it once more, at that particular point you can identify that that is a point corresponding to the minimum value of thermal resistance or maximum rate of heat transfer. That is the one we talk about as the critical thickness of insulation or critical radius of insulation. And that crossover point is just something like a representation at all, and nothing separate. Okay, so I hope you have got my point. If you have still any query, you can write to me with some details. You already have my mail IDs. You can write in the portal. You can write in my personal mailbox also. So thanks Arnav, thanks to all the other participants for listening. I expected a few more questions, but as that is not there, so I shall be stopping the session here itself. And I repeat, if you have any query, you can still write to me in the portal. I shall be happy to respond. Thank you very much.